Hello everyone, this is Ted. In this video you can see a small drone take off and record a team of us sedimentary geologists as we prepare to take a sediment core of tidal flats on Little Ambergris Key, part of the Turks and Caicos Islands. The coring technique we used is called vibrocoring, and we use a concrete vibrator like you might see on construction sites to shake the core barrel down into the sand. It felt like we were grabbing an electric fence, and we worked hard to guide the core as deep into the sediments as we could. But this one got stuck about halfway down, and I accidentally kicked my friend Annalise in the face trying to drive it through a crust. So I owed her a few dark and stormy cocktails after we lugged the equipment and cores back to the boat. Here's another video of us taking a vibrocore on Little Ambergris Key. You can see widespread dark polygons that are microbial mats growing all over this tidal bay. We wanted to see if the sediments below the mats contained any evidence that the mats were lithifying or being preserved for future geologists. This core got stuck too, and we made a futile attempt to hammer it through another shallow crust. Elsewhere on the island, we did pull up a few long cores and were completely surprised to find almost no trace of this widespread microbial ecosystem in the subsurface. We hope that lessons we learn from these cores will help us search more accurately for hidden signs of microbial life in ancient rocks. There's nothing more exciting than arriving at your field site for the first time. Here, a colleague Usha and I are being dropped off by a float plane on nearly 2 billion-year-old rocks exposed on a remote shoreline in Canada's Northwest Territories. I just wanted to brag and show you the view from our campsite on the Skeleton Coast in Angola, where we were studying Cretaceous rocks that formed as the Atlantic Ocean began to open between South America and Africa. I should have brought a surfboard. In these videos, you can see the deck crew of the research vessel the RV Nor recover a 40-meter-long piston core from the North Atlantic Ocean. This special piston core used a 60,000-pound weight to drive the core into the mud at the bottom of the sea. Pulling that huge weight out of the ground, lifting it over 5 kilometers through the sea, and maneuvering it back onto the ship's deck required some really special engineering. The stern of the Nor has a unique articulating arm that can move the core from the A-frame to the side of the ship, and then carefully choreographed winches can lift it onto the ship's deck. Once we got it on deck, we worked through the night to sample the mud and pore water in the core to reconstruct ancient ocean salinity during the last ice age.
Welcome to the Nowcliff Mountains here in Namibia. This is my field area, and it contains a variety of unique sedimentary rocks, many of which have been heavily folded and faulted, as you can even see from here. I work here to study the climate record of Snowball Earth, a period in Earth history about 635 million years ago, when the entire Earth was covered by ice and then suddenly melted. By studying these rocks, I hope to decipher the details of this massive transition. We began my field project here with a field course run by the Agron Institute, which was led by Caltech professors. This field course brought together scientists from all around the world to learn from and study this incredible collection of rocks. The Nowcliff is a remote and beautiful region in southern Africa, and from our campsite here, we are often treated with the hollering of baboons and the stomping of zebra friends all around.
Geoscientists often have to go to the field to do our research. That means sometimes going to places that are remote or difficult to access by conventional means, and for this reason, our division has access to a fleet of field vehicles. These are trucks or sport utility vehicles that are able to handle difficult terrain and travel around places that your normal city car might not be able to. One of our fleet vehicles is pictured here in this drone footage from a field trip a group of people from the department, as well as artists and storytellers from the community, took to an area called Carrizo Creek. This field trip is a special one for us because it was organized not by a member of the geosciences faculty, but by a member of the humanities faculty. It was part of a larger project meant to explore the relationship between landscapes and people, and explore the ways in which we document and describe landscapes and how those forms of documentation and description are used. Geologists are really familiar with the process of documenting and describing a landscape. We go to the field specifically because we want to observe it closely and collect data that will help us unravel its geologic history, structural history, its climate history, its ecological history as well. But landscapes have a lot of cultural and political significance as well. We draw borders through landscapes. We ascribe rights to various natural resources based on the shape and the history of a landscape. So this project was a really interesting application of some of the tools that we use for geoscience to a concept that is a lot more complicated and wide-reaching.